So in this video, I'm going to cover section 8.3, which is the beginning of this unit, which deals with quantitative variables, which leads us to sampling distribution about means. So here's the deal. We want to create a confidence interval for a sample mean. So we're going to use for our population mean. So we're going to use the sample mean as our point estimate plus or minus a critical z value times the population standard deviation divided by the square root of the sample size. But what's going to prevent us from doing this is the fact that we don't know the population standard deviation. If we did, we'd also know the population mean, and therefore we wouldn't have to calculate a confidence interval at all. So here's the deal. We need to figure out what is the best estimate for the population standard deviation because sigma is unknown. So if we're trying to estimate the population standard deviation, we're going to estimate it with, no shock here, the sample standard deviation. So now, instead of estimating one parameter, we're estimating two parameters. That creates extra variability. The extra variability leads us to have to use a different distribution besides the standard normal distribution. So what we need to do here is use something called the student's t distribution. It has some similarities and differences to the normal distribution. One of the similarities is it's symmetric about zero, it's single peaked, it's bell-shaped, it's perfectly symmetric. Difference is it has more variability than the normal distribution. And the reason is you're estimating two parameters instead of one. The third thing is as the sample size increases, the t distribution, the shape of it approaches the normal distribution because our sample standard deviation becomes a more precise estimate for the population standard deviation. So essentially, those of you who have taken calc at all, as n approaches infinity, the t distribution shape approaches the shape of the normal distribution. So we talked about some similarities and differences from the t distribution to the normal distribution. And it's extremely important why you understand why we have to use a t distribution, because sigma is unknown, the population standard deviation is unknown. We have to use S sub x, the sample standard deviation, as an estimate. So we have greater variation. So we use t as a result. All right. So moving on to the second page here, we're going to take a look at how to find critical t values because now we're not going to have a critical z, we're going to have something called a critical t value. So there's two things that we need to know in order to do this. We are going to need to know the confidence level and the degrees of freedom. So degrees of freedom is found by taking your sample size minus 1. And degrees of freedom is a very abstract concept. Don't get hung up on worrying what it is. It's just how you calculate it. So the sample size is 12 minus 1, 11. So for this one, a 95% confidence interval, that would mean there's 5% left over in the two tails. Split that in half. There's 2.5% left in each tail. So I would do inverse t, 0.025, comma 11. So let me bring up the calculator for that. So I'm going to go to the same place we always do, second vars, and I can see right here, inverse t. The area is the 0.025, and the degrees of freedom are, like I mentioned, the sample size minus 1. So in this case, 11. Paste. I'm ignoring the negative because it's going to come after the plus or minus, so 2.20. If I go to two decimal places, 2.20. Now I have a 90% confidence interval, random sample of 48. So sample size minus 1 is going to be 47 degrees of freedom. 90% confidence leaves 10% in the tails, divided by 2, leaves 5% in each tail with 47 degrees of freedom. So if I go back to the calculator and I do this, inverse t, 0.05 with 47 degrees of freedom, now I'm looking at about 1.68 approximately for my critical value, 1.68. So these are critical t values with your degrees of freedom listed as a subscript. So at this point, pause the video and work through question number 1 and question number 2. Make sure you can do this skill on your own. They keep referencing table B. We're not going to use that. We're going to use our calculator. So in number 1, 96% leaves 2% in each tail. So this is going to be inverse T, 0.02 with 21 degrees of freedom, which is about 2.189 or 2.19. Second one, 99% confidence leaves 0.5% in each tail. 71 observations, so we have 70 degrees of freedom. And this is going to lead me to a critical value of 2.648. So you need to be able to take a confidence level and a sample size to find the critical value. Moving on to the third learning objective. This is your conditions. 2 of the 3 are exactly the same as they were for categorical variables. Random and 10%, those are the same. Normal and large sample. We talked about this quite a while ago when we talked about sampling distribution, so this is going to look a little familiar. So random is going to be either a random sample or a random assignment. And that's so we have an unbiased sample, it's centered at the true value, and we can generalize to the population. Or if it's random assignment, we can conclude cause and effect. That would be from an experiment. 10%. The sample size less than 10% of the population. So what? Because we're sampling without replacement, make sure that's okay. The normal/large sample condition, there's 3 scenarios you can encounter. First scenario is they tell you the population is approximately normal. Great. Then the sampling distribution is approximately normal. The population is not approximately normal, but the sample size is large enough. We say greater than or equal to 30. That's our central limit theorem at play. That would mean the sampling distribution is approximately normal. And if the shape of the population distribution is unknown and your sample size is not at least 30, then we have to look at a box plot. We could look at a dot plot, we could look at a stem plot, but the box plot is going to be what I recommend because that will immediately tell us if we have any outliers. And you will always have to include this graph as part of your 4-step process if this is the scenario you find yourself in. All right.